So we can draw a quick diagram of the system here. And then we can say that then so this would be a quick diagram of the airplane traveling from city A to city C through city B. So we have angle here phi, angle here theta. We're going to label this point A, label this point B, label this point C. We know that we can label this point D as well, and we can simply say that this would be BC cosine of phi. We would know this through trigonometry. And here we have BC sine of phi. And so we can say that, my apologies, this would be A. Say that if we consider the triangle ADC, so ADC, we can say that then AC would be equal to the square root of AD squared plus DC squared. And we know that the value of AD is equaling AB plus BD, or in this case, BC cosine of phi. So we can say that then AD is going to equal to 200 kilometers plus 300 kilometers multiplied by cosine of 30 degrees, or angle phi. And so this is giving us 459.8 kilometers. We can then, we know that DC is equaling BC sine of phi. This is quickly found by substituting, again, 300 kilometers multiplied by sine of 30 degrees. And this is giving us 150 kilometers. So now we can find AC and say that then AC is equaling the square root of 459.8 kilometers quantity squared plus 150 kilometers quantity squared. And we find that then AC is equaling 483.655 kilometers. We could round to 3 significant figures and say that then the distance between city A and city C is equaling approximately 484 kilometers. Now the direction, that would be for part A. For part B, the direction of city C from the city A, we can say that then tangent of theta would be equaling to DC over AD. This is giving us, or rather we can solve for theta. Say that theta is equaling arctan of DC over AD. So theta is going to be equal to arctan of 150 kilometers divided by 459.8 kilometers. And this is giving us 18.1 degrees north of west. So this would be rather our two final answers here for part A and part B. And part C, We know that then the answers calculated in part A and part B are, we can say, part A and part B are approximately correct. And this is only because we're dealing with distances that are significantly large. And so when we're dealing with distances that are significantly large, we have to account for the curvature of the Earth. So they're only approximately correct. We can say not accounting for the curvature of the Earth. That is the end of the solution. Thank you for watching.